portion of our training film, we're going to use the inductive coupler as a method to apply signal to a locate. The inductive coupler is nothing more than a split ring current transformer. We have a small size which is good for 3 5/8 inches inside diameter, which we call our IC49 inductive coupler. We have an IC56 inductive coupler, which is good for 5 5/8 inches inside diameter, which means it could be used around a 5-inch primary conduit. The inductive coupler, and it is produced by other companies in various sizes, the inductive coupler is a very, very good way to learn to use a locator. But it's not the only way to use a locator. And so often I see people that really, they've had some pretty fair luck with an inductive coupler, and it is a great accessory. But there are times it can really get you in trouble. And I think maybe it's even oversold a little bit. To be a locator, you need to learn all of the methods. So up until this point with inductive couplers, it's very important that you go back if you don't understand the first portion of our training film, which covers the direct or conductive tracing. You need to be a master now at inductive tracing, because as I said, the inductive coupler is only another tool. Like the light on a conductive trace, we said that the switch must be closed in order to turn the light on. That's also true of an inductive coupler. With direct tracing or conductive tracing, we have a ground plate that we put into the ground. With the inductive coupler, the soil itself becomes the closed loop, so that when I place an inductive coupler around that cable right there, the tone will take off in both directions. Now, since the cable is grounded at both ends, and that is a must, the inductive coupler will only work on a cable that is grounded at both ends. If one end is open, or if both ends is open, the inductive coupler will not apply signal on the line, because the signal must be getting the ground at both ends. It uses the earth as its return path. Just as when we closed the switch, we had a closed loop. Our closed loop is here when we have an earth path. So the cable must be grounded or tied into ground through a load. It could be a hot lead tied through a load to ground, because it must have that ground path to follow. If we had another cable that came out here and just kind of dead-ended, we could put the inductive coupler there and no tone would go out on that cable. Now, since the return path is through the soil and the tone comes this way, one thing that an inductive coupler does is it restricts the amount of tone on the line that you have it connected to. Lots of people sometimes say the inductive coupler isolates. That is a false statement. The inductive coupler does not isolate. And on the next picture that we put up here after we erase and remove this one, I'll show you the signal levels to where it restricts the tone on all of the other utilities, and it will maximize the tone on the one you clip it on, but that still can get you in trouble, as we'll show you. Right now, since the tone is in this area, and since the tone is restricted to this cable, very little tone is going to be on this one, we can locate that cable with absolute assurity that that's the one we're on. If we wanted to locate this cable, we would have to move the coupler to that point. It too is grounded at both ends. We can identify that cable from all the rest. We can clip on right here. We can identify that cable from all the rest. We clip on right here and it won't work. Why? Because the cable is open circuit. This is why a street light during the day when the photocell's open, you'd not be able to use a coupler on. After the photocell's closed, if we can put a hood on it to close it, or at night, it may work. Give you an example of when the tone will restrict itself to the line that you're on and when it will not, because at times it will not. At times you can clip onto a line and have tone on everything, just like conductive tracing. And let's see when that is. If we would clip an inductive coupler on that neutral right there, we could literally isolate that cable from these two, because most of the tone would be on this line. There would be a little tone on these two cables, but the big tone would be on that cable. And now when I pick up a receiver and I start making a locate, I will start out, if I've clipped onto this cable right here, we'll say that's a cable. When I start out, I'm going to take a reading and I'll pick up a reference here on the meter at a given sensitivity setting, and then I'll keep walking around looking for something more. The fact that I picked up tone right here does not mean this is the cable that I'm on, because there will be tone on those other two cables, and it may be coming up enough above ground to a point where I can pick them up. So normally I start on the strongest tone, but I walk clear around the cable I'm connected to pick that strongest tone up. Now, let's take a look at another situation here. It's an identical one, but it's probably more likely the one that you're going to see inside of a transformer enclosure. Over here, I had the three neutrals going to the ground rod right here. Notice here that the three neutrals do still go to the ground rod, but they go to a tie terminal block right there. And then there's a long copper wire that goes down to the ground rod at the base of the transformer enclosure. If I were to put the inductive coupler right there, I would not restrict tone to that cable. Why? Because notice up here, when I put tone on here, tone went to ground, and it went to ground and started back before it could get on this other cable. Here, tone goes to ground before it sees, the tone can see these other two cables. Not the case here. When tone goes that direction, down that cable, it's also going to enter this area right here, and it can physically see those two cables before it sees the ground. Well, its tone is going to go out on them two cables then, and so we're going to have an equal amount of tone on all the cables in this situation. So the rule of thumb is that if the tone sees ground before it sees another utility, it will restrict the tone to that line that we're on. If the tone can see other utilities before it sees ground, it will not. The tone will divide out. Now, a couple of areas you can get into trouble. The first one is that you ground your neutral to the cold water line. And along some other utility, we'll not pick on the telephone company, but let's just say the telephone company decides that they know that you're going to ground, and it's going to use a lot of cable for them to go to that water pipe also. So why don't we take our cable and we'll ground to this power neutral right there, because we know they're going to the water pipe, and that makes it a legal connection. The problem is that you're going to come along with your inductive coupler here, or direct tracing, and the tone starts that way, and it sees this conductor before it sees the water pipe. So tone will split and go on that line. Had they grounded to the cold water line, like this other utility did, tone goes down and sees the cold water line, which is ground. It won't go out on that line, that guy right there. So again, the rule of thumb, if tone can go to a conductor before it sees ground, it'll go to that conductor. If it sees ground before it sees the conductor, then it will tend to isolate. One thing we could do to prove this point, if we would take and clip on with a battery jumper cable right there and jumper that down to the ground, and then break that circuit loose from that block, tone would go this direction, but it would have to go down this cable to ground before it could get back up. That then would isolate that line. Another problem we have is with primary power cable, and this is where we're going to actually have an elbow coming up here on this cable, and we'll make this a single phase. We've got another elbow, and they've taken the neutral, the concentric neutral, and they bring it around off of both cables, and they put a split nut right there, and then they take that down to a ground rod in this area. Well, when you place the inductive coupler right there, the tone goes this direction okay, and then when the tone starts down that direction, it gets to this point, and it physically sees that conductor before it can see the ground rod, so it won't isolate. It would be ideal if we had two primary cables and standards had put the thing in so that this concentric neutral went to ground, and this one also went down to ground, so that when we put the inductive coupler on that one, now we would tend to isolate that line from the other one. If you do run into some of the systems, which we do see them in the field, where long pigtails are made to the ground rod, but sometimes this wire just absolutely comes over and wraps around because it's long. In this case, put on your rubber gloves and move that wire physically so that there is no mechanical or no electrical connection between the two at that point. Pull them apart so that tone doesn't make connection there. It physically has to go to ground before it can see the other line. Then it'll isolate for you. Now, let's go on to the picture. I made a statement earlier that with the inductive coupler, tone does not go out only on the utility that you clip around. So let's get rid of this, this picture right here and show you how to make a locate then with your inductive coupler and to literally isolate your line from all of the others. All right, picture 1 here is identical to picture 2. And over here we're going to say this is our power cable, and this is going to be the power cable, and this is other utilities that may be in the ground. Notice that they're varying depths, so that when we place an inductive coupler right here, we've got a whole bunch of tone on that line right here. There's only a little bit of tone on this guy, and there's only a little bit of tone on that guy, and there's only a little bit of tone right here. You see how this little bit of tone right here, even though this amount of tone is actually smaller than this big amount of tone, to the receiving antenna above ground, it looks bigger. Because regardless of what manufacturers, and some will tell you, only trace going away from their transmitter, never trace going to. The receiver doesn't know where the transmitter's at. You can trace going to or going away from the transmitter, and it doesn't make a dime's worth of difference if, in fact, the receiving antennas are in the center of the receiver. In other words, if I would take and put my antenna over here, then I would, if I were to make a mark on this locate, if the antenna was really over here, it would be over this cable, and you're marking below the center, so you'd be marking there, when in fact, now the reason they tell you don't go another direction is because if I turn around, this antenna now is over here, it's over that same cable, but now you're marking the ground over there. So if the antenna is not physically located in the center of the instrument, then I can understand why somebody would not want you to go one direction. They would minimize the error or cut the error in half by only going one direction. But it's probably a good idea to go with any manufacturing company, take the instrument that you're using, even if it's an Aqua-Tronics instrument, and verify on a cable 180 degrees to make sure that the antenna is in the center, so that the marking point that you make is going to be the same regardless of whether you're going to or from your transmitter. Because the receiver doesn't really know north from south, it doesn't know where the transmit, all it sees is that radio wave. Transmitter knows how to put tone on a line, receiver can pick up the tone, and it picks up the tone that's coming up from below ground, which may not come up straight. In this particular situation, this line is the strongest reading. So how can we solve that? Because we're picking up this line, we know that this is a little bump and a little bump, and that's a pretty good sized bump there, and this is a smaller one, and we're not sure. One method is to use the inductive coupler on the other utilities. You're not going to hurt the cable television by clipping onto the cable TV service drop right there. That's going to put a whole bunch of signal on him it's going to put a little bump right there. Now, but when you put the big signal on the cable TV by being clipped around it, you now know where you're not. And sometimes by not knowing where you're not, you will literally find out where you are. Because then if I clipped around the telephone, it would have the big bump, and then this would be reduced again. Clipping it on here, this would be the same size, except this would become large. So see, by clipping the inductive coupler around on the various utilities, we can find out where we are and we can find out where we're not. Here we have an open transformer. We're going to place the inductive coupler on this particular cable. We'll use the inductive coupler on the primary. So we'll get the transmitter out and set it here. Before we place that coupler on the cable, we want to put on rubber gloves. One should remember we are working high voltage cables and the safety involved. So I always use rubber gloves whenever I put a coupler around a cable, or make a direct connection, because we could make a direct connection to this neutral right here and using our ground plate assembly, but right now we're going to use the inductive coupler. We probably should not put the inductive coupler around the conductor itself, in as much as that we have the safety hazard of being on the high voltage side without the protection of neutral, but we also are going to have some electromagnetic shielding from that concentric neutral, which would prevent some of the radio waves from getting up above ground. So we can either connect the inductive coupler around the neutral itself, the takeoff going to the neutral bus bar connection, or we can reach in around the cable. And this is normally the way I do it. I just put it around the cable right there, turn my transmitter on, and go make my locate. We probably would not get isolation of this cable using an inductive coupler, because as we were talking about on the blackboard, all these neutrals are tied together right here on one main bus bar. And then a single wire goes on down to a ground rod, which is driven into the hole here, which means that the tone leaving this inductive coupler can actually see the other two neutrals via that connection right there before it sees ground. So we lose our isolation. Now we're going to move the inductive coupler over onto the secondary cable right here. Again, we would just clamp around the cable that we were trying to trace out to the house, or the neutral. And again, from the neutral, we could use the direct output of our locator using the ground plate assembly. Pull out the neutral wire you want, clip around it, let it hang. You would not be getting isolation off of any of your locates in this transformer of this type, because notice that all the neutrals are tied together there. If we have the secondary right here, all of the cables are tied together. And as we said again on the blackboard, when we place the inductive coupler around a cable, if the tone can go up and see another conductor before it sees the ground or the termination, and it would see ground through the transformer in this particular situation, if it can see another conductor first, then it will not isolate. You'd literally have tone on all of the cables in this area. So direct output to the neutral or inductive coupler to this secondary cable, either way, you would have tone on everything. We're here at this house, and we chose this spot because we've got a power meter, riser, and a gas meter together. And we wanted to show you how to use the inductive coupler on both of them and show you where some of the problems can be with the gas meter. We clip around the meter riser right there. We can turn our transmitter on and we can go make our location to the transformer. See the driven ground rod right here. Often we will see these when the water company has either brought in a plastic line or the water meter is, the water pipe is on the other side of the house and they really can't reach it with the ground of the power line. Even if we pulled a meter on this meter riser right here, this connection would still work and we could still go make a locate, because the neutral does not break when we pull the meter. The two hot legs become dead-ended, but the ground is still intact. So with the grounded cable at both ends, the inductive coupler will work and make a very successful locate for you. In this particular situation, this would not be the case. And the reason for it is gas meters always have a plastic insulating gasket right at this point above their shutoff valve. this insulating gasket makes this pipe electrically look like the dead end of a pipe, just like you would have cut it off. Well, the inductive coupler has to have a line grounded at both ends, so we could run a battery jumper cable up and bypass this meter completely by grabbing the pipe here so that we bypass that electrical connection, and then the inductive coupler would work. And I don't recommend going to one of these screw heads, which I have done, but I've also got into trouble doing that because I found insulating gaskets sometimes on this side of the meter too, and also the gasketing inside the meter sometimes will isolate different sections of the meter electrically. Even though mechanically they're secure, electrically they become an insulator, and so the inductive coupler wants to act like it's on a dead end of a pipe. So I always jumper from this shut-off valve right there over to this section of the pipe and make sure none of that gets involved in my reading. Once I've done that, then I can use the inductive coupler on this pipe. And of course, sometimes we see plastic pipe coming up, and at that point they use the wire tracing wire. If they have a tracing wire there, the inductive coupler will not work unless you ground that tracing wire via a battery jumper cable and screwdriver at both ends. In this particular situation, battery jumper cables sometimes can be a nuisance, and you'd be better off just taking a direct connection, hooking up with your ground plate assembly as we would with a tracing wire or this gas pipe. We're here at this meter riser, and we're going to use the inductive coupler to make a trace from the meter to the transformer on the secondary cable. First thing we want to do is open up our instrument case and take out our transmitter, which we have here, and then we're going to take out the inductive coupler. Now, all we have to do is with the inductive coupler, clip it around the conduit, make sure the inductive coupler is closed. We're going to take the plug from the inductive coupler, plug it into our transmitter, turn the transmitter on, make sure the function control is on tap number 1. With the Aqua-Tronics instruments, tap number 1 is the correct impedance match for our inductive couplers. Other instruments that you have, if you have impedance matching on them, you'll have to check with your instruction manual to see what they may be. But with the inductive coupler plugged in, the function control on tap number 1, the power on, we can now pick up our receiver and make our locate. We're here at this house to make a locate. I have an inductive coupler clipped around a meter riser, and we're going to trace the secondary out using both the null and the peak. I want to show you some things that you do when you're locating, but I also want to show you some things that you don't do when you're locating. I want to show you a couple of techniques that I use in locating that I think makes my job a little bit easier when I'm out on the street. We're going to start out in the null mode. Remembering the null mode is where we actually lose the tone over the route of the cable, and we'll have tone on both sides. Notice how we're getting this loss of tone when the antenna is pointing right at the cable and vertical to it. Notice also that when I'm locating, I do a rotate with my receiver. I'm rotating this receiver around this way, and we'll show you why. I'll do this also in the peak mode. This loss of tone we're getting the null reading as we trace the cable on out. Now I'm going to switch it over to the peak mode. Notice that just like when the antenna in the vertical mode for the null reading, we were pointing at the cable. In the peak mode, it's going to be the same way. Notice that we're going to have a peak reading. We're going to lose tone here, and we're going to lose tone there. Notice that we turn sideways, we have no tone. So the cable is right angles when we do a twist. I'm going to take advantage of that to help me stay on this cable. Notice that when I walk, I do a slight rotation, and we'll come back to that in just a moment. But first of all, I want to step off to the side and show you why you never swing a locator. Notice that the antenna is actually going to peak up right there. Here we really aren't locating cable at all. But if you get into a fast swing and you're dodging traffic, it's very easy to be marking the ground here when in fact the locator's telling you the line's over there. Keep the antenna parallel with the ground, but don't be afraid to do a rotate, because if the cable was going that direction and I'm this way, I wouldn't see it. there I would. Let me show you what I mean. I'm going to run it the way most people are going to run a locator, and I'm going to move it back and forth, keeping parallel with the ground, just like we're supposed to, as I trace this out. Notice all of a sudden the tone is dead and gone. I've walked off the end of the line. It's made a turn and gone somewhere, and I didn't turn with it, simply because I wasn't 90 degrees with it any longer. And the sad part of it is that there may have been another utility running along right here that I would have picked up, and I would have not known my line turned. So let me back up and show you the proper way that I use, the way I use the locator, which I think is proper, to make a trace. Notice how I'm doing this rolling of the locator. Notice how it's picking it up over in that part of the roll. Effectively, I've made my turn just by looking at more than one angle on the cable. We've started out in the null mode. We've shown you how to use the locator in the peak mode. We've showed you why you should never swing your locator, because it can create problems to you when you're in the street locating. We've showed you a technique of rolling the locator that maybe make the job a little easier when you're walking through turns in tracing a line out. Let's go back into the classroom now and continue on. That is a summation of the inductive coupler. It's a good tool to use. Right now you should know when to use the coupler, when not to use the coupler. For instance, if the cable is open at one end, can't use the coupler. If you pull a meter out, you could still use the coupler, because the neutral does not break when you pull a meter. You must be very careful, though, how you apply an inductive coupler to a locate, because if you use it improperly, you may not get the locate that you think you're getting. But when it's used properly, an inductive coupler is just like the other methods of a locator. It's God sent and can really bail you out of a lot of problems.